Hello guys, welcome back to Maison African Motives. Still working on engineering science N3, that is working on revisions. We have got the question on forces that we are going to work on, that is from the question paper of August 2017. So that is question number 3. We are given the first part of our question 3.1, that was to name 2 principles that will be applicable if more than 3 coplanar forces, take note, act on an object and the object remains in equilibrium. That is the most important part that we need. The object must remain in equilibrium for any number of more than 3 coplanar forces. All right, so what are these conditions that we need? All right, so here I've got some of the conditions that we can consider. That is the first part that we are given. The vectors of the forces form a closed triangle. So that is what a condition that you're going to have in equilibrium. It must give us a closed triangle. The second part that we're going to have is the algebraic sum of the components of forces in any direction is equal to 0. Then the sum of the moments of forces about any point is also equal to 0. Then the lines of action of forces meet at a point, and also the forces of vector are coplanar. So meaning to say any of the 2 that you are given here, we are going to use it to attempt or to answer this typical question, any of these 2 that we are given. All right, so that was the first part of our question. Then we consider our second part, which is on question 3.2, where we're given fig 2 shows number of forces acting on a point in the same plane. So this is the condition that you are given, and we are asked to calculate the following: the sum of the horizontal components and the direction. All right, so whenever you're given this type of a question, what you need actually is to work with the forces as you're given from the diagram here. So what you're going to notice is that if we are to have this extended line from our horizontal line, this horizontal, that is representing the east and the west line. All right, and also we indicate our north pole. In this case, we are going to have our north pole at this point. All right, so this is our north pole here. So I want us to consider our forces that we are having here. Whatever force that you have must be taken from the point of contact of these forces here, the 3 forces that we have. It must be taken from this point. So if we take note, the 25 Newton, the 24 Newton, this one that we are having, it's from the point, which one, this one, which is fine. But if we check, the 45 Newton is taken into the point. So what you're going to do is to extend this one, because it must be from the point. So what you are going to simply do is to extend the 45 Newton that we are seeing here. We simply extend this force. All right. So if we extend this force, now it is going to be taken away. The arrow is supposed to be pointing away from the point of contact. All right. The same thing that is going to happen with the 30 Newton, it's pointing into. So we are going to extend also this one out like this. All right, so that it is going to point outside. So this is our 30 Newton, and the other force that you are given here is the 45 Newton. All right, so since we are to calculate the components, which is the horizontal and the vertical, I said each and every force that you're supposed to be having must have this concept to say it is supposed to be taken, the angle that is affecting that force is supposed to be from the horizontal line to the given line. So whether your line is from this part here, we are going to take from this horizontal line to, so we need the angle between the force and the horizontal line. Whether it's in this quadrant, we need the force, the angle between the horizontal and the force. Whether it is in this quadrant, we need the angle that is between the horizontal and the given force. So this is the condition that you must consider. So meaning to say here we are supposed to determine or to find this angle that is affecting 45 Newton to the horizontal line. So we need this angle between the force and the horizontal line. Also on the 30 Newton, this one that we have extended on this part, the 30 Newton, we also need the angle between this force and the horizontal line, just like what we are having on the 24 Newton, this one, the 30 degrees, it's between the force and the horizontal line. So this is actually fine. So here we are not going to have anything. We are going to just leave it like that. All right. So what is it that we can do? How can we determine these other angles that we are given? All right. Let us consider what we have on this part, on the 30 Newton, okay, on the 30 Newton part that we are having here. We extended the 30 Newton direct here. This is a horizontal line, meaning to say from the horizontal line, just like this part here, we've got a horizontal line. Then we extended the force of 30 Newton like this. This is what we did. So meaning to say the angle that we are seeing in between here is the same as the angle that we are going to see, because these are two straight lines, and these two angles, they are referred to as vertically opposite angles. So meaning to say this angle that we are to calculate from this point up to this point is the same as the angle that we are seeing from this point up to this point, this angle here. So how are we going to determine this angle? This is our question. Taking note that this is a straight line, and we know that angles on a straight line, they add up to 180 degrees. So attempting or using this concept that angles on a straight line add up to 180, we are simply going to subtract these other forces that we are given. Okay, let me remove this part here. We are going to subtract these other angles that we are given, the 30 degrees, the 35, and the 75 from 180. So we are going to have 180 degrees minus 75 plus 35 degrees plus 30 degrees. All right, so meaning to say our angle here is going to give us something like 40 degrees. All right, we are going to obtain 40 degrees in all in all. So meaning to say if this angle here is 40 degrees, it means this angle is also 40 degrees. The angle that is between the force and the horizontal line. This is what we need. All right. Then we also ask ourselves, what about this angle between the 45 Newton and the horizontal line? Just like this concept, the force and the horizontal line. What is the angle between? Which concept are we going to use in this case? If we check, we extended this part from the 45 Newton, that is where we extended this line. So meaning to say, between the horizontal line and the line that we extended, this angle is going to be the same also as this whole angle, this one, from vertically opposite angles. So meaning if we add 30 and 35, we are going to obtain this angle, 30 plus 35, which is 65 degrees. So this angle between the force and the horizontal line is 65 degrees. Okay, now with these forces, guys, everything is going to be very, very easy for us. All right, let me redraw this on this part so that you can properly understand what I'm saying. So we are going to have our forces just the same way we are given. So like I said, we need to take this from the North Pole. So we are going to have our North Pole in this case like this. And also, okay, just a little bit, guys, you understand what I'm trying to say here. And we are going to have our east and west part in this case. All right, so meaning to say, here we are having our north. This is the most important part to indicate our north. Then we've got our south, our west, and our east. All right, the first part that we are given from the horizontal in this case, that we said is actually fine. This one is taken out of from the point going out the 24 Newton. So meaning to say we are going to indicate our 24 Newton at 30 degrees. So this one, guys, is just a sketch that I'm indicating here. So we are going to have our angle here that is of 24 Newton in this case like this. All right, so this is what we are given. So that is taken outside. So we've got our 24 Newton taken from the point of intersection of the forces, and the angle in between this force from the horizontal line, this is our horizontal line, is 30 degrees. So we have got the angle here of 30 degrees. All right, then we said this part, we are not going to work with it because it's pointing in. So we're going to take this one now that we extended, that is now pointing outside, which is between the 40-degree angle. So we're going to have this force like this. All right, so this is what you're going to have. So this is our 30 Newton now with the angle in between the force and the horizontal line, which is 40 degrees. So this is our angle here of 40 degrees, the one that we calculated. Then we have got the last force. Remember, 45, we are not going to take this. We are going to take the one that we extended, this one that is now from the point of intersection of these forces. So we are going to have our 45 Newton somewhere here. All right, so this is the force that we are going to have. And also, we had the angle. So let me just remove this. And we had our angle in between this force of 45 Newton, this angle that we calculated 65 degrees. So we are going to indicate our angle from the force to the horizontal line. This is the part of our horizontal line. This is 65 degrees. So this is how our diagram was supposed to be in actual sense. Once our diagram is like this, we can easily calculate whatever that you want because our forces, they are taken out of the from the point of intersection, and also each angle is indicated from the force to the horizontal line, from the force to the horizontal line, force to the horizontal line. So the question is, we are supposed to calculate, that is the first part, calculate the following 3.21, the sum of the horizontal components and the direction, 2 marks for that. All right, so what are we going to do in this case? From our diagram, we are going to focus with this diagram now. So we need the sum of the horizontal components. All right, so this will be our question 3.21. So the sum of the horizontal components, which is given as from your formula sheet, it's actually given as fx. That is for the horizontal. So meaning to say we are working with the cosine of theta. Remember, I said horizontal components, they use the cosine of theta. And also, I said from our revisions, it is very, very important for you to note this. If you are dealing with the horizontal, whatever that is on the right side is taken as a positive. Whatever that is going to the left side is taken as a negative. To the left side, it's a negative. All right. So let us start with 24 Newton. So 24 Newton is from this point, it's on the right side. So it's a positive. So we are going to have this as a positive. So it's 24 cos. Remember, horizontal uses cos. So it is going to be positive 24. The cosine of the angle between that force and the horizontal line, which is the angle of 30 degrees. So we are going to have 30 degrees. All right. So this is the angle that is affecting the 24 Newton, which is 30 degrees. All right. We move on. We have got the force of 30 Newton. Also 30 Newton, if we check the side, it's on the right side. It's not because of down. The down part, it's on the vertical. This, we are talking about the horizontal. We are talking about being on the right or being on the left. So on the right, we said it's a positive. So that is going to be plus 30 Newton cos, because it's a horizontal. So it's going to be cos theta. So the theta is the angle between that force and the horizontal line, which is 40 degrees in this case. All right, we move on to the 45 Newton. From the given point, from this point, it's on the left side. On the left side, it's a negative. So this is going to carry a negative. So that's negative 45, the cosine of theta. So our theta is the angle between the force and the horizontal line, which is the 65 degrees. So like I said, if you have got your information like this, it's easier for you to calculate whatever that you want. All right, so we are going to simplify this. From our calculator, you obtain something like 24, 74. So that's 74812, 74812, and so on. That is in newtons in this case, to 3 decimal places. That is in newtons. And the direction, it's a positive answer that we got, and this is what we got. A positive, that it means we are going to the east. A negative, that is we are going to the west. So meaning to say our answer is a positive. So meaning to say the direction in this case is to the east. All right, so that is what we got in this case. All right, so let's check the other part of our question. We are supposed to determine or to calculate this time the sum of the vertical components and the direction. All right, so what will be for the vertical components, still working on this diagram that we are having here that we redrew this time. So we are going to focus on this diagram. All right, so we need the sum of the vertical components in this case. So that's 3.22. So the vertical components are referred to as Fy. They use the sign of theta, vertical sign of theta. So meaning to say we are going to take our forces multiplied to the sign of theta, and also noting this concept to say if it is a vertical, remember it's vertical, so it's either we are going up or we are going down. So when we are going up like this, that is where we are having a positive, that is to the north. And if you are going down, that is a negative, meaning say to the south. So whatever that is taken below the horizontal axis, below it's a negative, above it's a positive. So that is the concept that you're going to use for the vertical. So let us start with the 24 Newton. This point, we are referring to the horizontal, this part. It's above, it's on top. So meaning to say it's a positive. So we are going to have positive 24. The sign of theta, it's a vertical. You are working with the sign of theta. Theta being the angle between the force and the horizontal of 30 degrees. All right. If we check 30 degrees, 30 Newton, it's below the horizontal line. Like I said, below the horizontal line, that is a negative. So this is going to be taken as a negative. So that's negative 30. So we are going to have negative 30. The sign of theta, which is our theta, is 40 degrees. We move on to the 45 Newton. Again, it's below the horizontal line. So it's a negative. So it's negative 45. The sign of theta, our theta is the angle of 65 degrees. All right, so this is going to give us the sum of everything that we have on the vertical components in this case. All right, so if you are to simplify, we are going to obtain a negative value. We are going to obtain a negative of 48, comma, that's 0.6747, which is 0.67 in Newton. So the negative that we are seeing, like I said, negative, we are going down, meaning to say we are going to the south. So meaning to say, if we are to write, we are going to write our VC as 48,067 Newton. But the direction now, this is to the south because it was a negative. So a negative meaning to say we are going to the south. All right, so that is what we are going to have in this case. All right, so that is how you answer these typical questions. Now we need the magnitude of the resultant and also the direction of the equilibriant. That is what we need in this case. Remember what I said, whenever you are working with the resultant, what you need is to focus with what you calculated from the vertical and the horizontal components. All right, so we are going to have another equivalent. This is actually a diagram for the equivalent or the resultant. If you check, we calculated, it's no longer from this diagram. This diagram gave us the sum. So from the sum of horizontal, from the sum of the vertical, that is where we are going to obtain now the equivalent triangle that we are going to use to calculate this part of the resultant. All right, so maybe, okay, let me just have a smaller diagram. Maybe it can just help us. A smaller diagram that we're gonna use here. All right, so what we are going to have, just like the previous part, we need from the vertical and from the horizontal. So we're going to have from the horizontal, that is our east and west line. Then we have got our north and east line like this, or west, that is north and south in this case. All right, so what we need is from the resultant that we have, we are ask ourselves to say, from the components that we calculated, the horizontal is going to the east. All right, this is what we have. It's going to the east. Then if we check to the east, meaning to say we are following this direction, always your resultant triangle it's either it is going to be like this in this quadrant, or it's going to be like this in this quadrant, or it's going to be like this. This is how you take your equivalent triangles. All right. So you ask yourself, like, where are we having our horizontal? It's going to the east. It's a positive. So to the east, meaning to say we are following this east line. That is where we are going to the east. All right. We are following the east line. All right. So let me just use a ruler since I'm having it. Let me just use it here. So we are going to follow the east line in this case, like this, maybe up to this point. We are following the east line. So from the east line that we are having, that is where now we move on to say, okay, after that, where is the vertical going? Is it going up or down? It's a negative. It's going to the south. So meaning to say, at this point, we are going to have our vertical component going down. So we're going to have our triangle like this. The vertical component is going down. It's a negative. So that means we are going to have our triangle like this being your horizontal component, this being your vertical component. So at the end, definitely, we are supposed to join these 2 points to have our resultant in this case. So this is representing your resultant. So like I said, our horizontal component was a positive. It was going to the east. So this is 24,748 newtons in this case. Then we have got our vertical going down, which is a negative. So that's negative 48,067 Newton. All right. So we need to calculate our resultant, which our resultant does not even affect because we just know that from our Pythagoras theorem. Remember, this is at 90 degrees. So meaning to say we are going to have our resultant. All right. So 3.23, our resultant from Pythagoras theorem, it is going to be the square root of the horizontal component. Remember, we've got horizontal and vertical. So it's the square root of the horizontal component squared plus the vertical component squared, which is going to give us the square root of our horizontal. That's 24,748 squared plus the vertical component, which is negative 48,067 squared. All right, so this is going to give us the resultant in this case. So our resultant from these values, we are going to obtain 54,06385 and so forth, which is 0634 if we round off to 3 decimal places in newtons. All right, so check if you, even if you do not use a negative, yes, still we are going to obtain the same answer. That is what is important. All right, then we need now the direction. So the direction of the equilibrium, this part of the direction, this is the most important part of having this diagram, because on your diagram you can simply see that, okay, according to what I'm having here, our direction is this angle that we are having. That is the angle between the east and the south. Our angle is between the 2 poles, the east and the south. So it's from east going to the south. So this is what we already know from our presentation, that we are going to have an angle. So, okay, let me just have it here, 3.24. All right, so we are saying our resultant, our angle, so which is the equivalent angle in this case, is going to be taken from the east going to the south. So we do not know the angle that we are going to have between, but we know that it is going to be from east to the south. All right, so we need to calculate this theta that we are given, which is the angle between these 2 points. So you see the importance of having your diagram. You can note the direction. I'm from east going to the south. All right, so how do we calculate theta? According to what we have, this is opposite and this is adjacent. So meaning to say we can apply the ratio of tan of theta to calculate our angle in this case, knowing that the tan of theta is equal to the opposite over the adjacent, that is the vertical component over the horizontal component. So we have our vertical component, negative 48,067. So this is going to be tan of theta is equal to negative 48,067. So that's 067 over the horizontal component, which was 24,748. All right, so this whole part here is the for tan of theta. What about the tan of theta? So it's either going to have this as a decimal, or you can simply express the tan of, the theta as the arctan of everything that we are having here, which is 48.067 everything over 24,748 like this. So what do I mean in this case? Simply from your calculator, arctan, that is shift tan, you express this, you're going to obtain something like 62, negative 62,758 degrees. So the negative that you are seeing on our answer is just an indication that the quadrant that you are working with is not for tan, is the quadrant for cos. So definitely tan is going to be a negative. But what we need here is this angle 62, comma. So meaning to say our direction in this case is going to be east. The angle theta that we calculated as a positive, which is 62,788 degrees, going to the south. So this is going to be your direction. So like I said, the diagram that you are given helps you to obtain or to see your direction. Where are you referring from to? All right, so that is how you attempt these typical questions in an easy way. That is going to help you a lot. All right, then 3.3, we are given to study fig 3 and answer the questions. All right, so this is the fig that we are given. All right, so we've got 1 kilonewton applied at this point. We do not have P. We have got R in this case. This is what you're given. All right, so our question. All right, so let's check the part of the question that we are given from this information or from this diagram that we are seeing here. The first part of our question is 3.312. Determine the magnitude of the left support P. All right, so we need to calculate the magnitude of the left support, which is P. As we can see, truly, we do not have P in this case. All right. Which concept can we use? As we can see, these are forces which are simply acting like we can just take it to the horizontal, where we have got the force of P and we have got our R in this case. And we have got this 1 kilonewton applied as a point load like this. We've got 1 kilonewton, 0.75 kilonewton. So how can we calculate P? Since we know from the sum of forces from the forces that the sum of forces up should be equal to the sum of forces down. So we can attempt this typical question, since we know that the sum of upward forces must be equal to the sum of the downward forces. In this case, the upward forces, we are referring the forces which are pointing up, the supports. That means P plus the other support R in this case, which is 0.75, must be equal to 1 kilonewton, which is the downward force, the one that is facing down. So meaning to say our P is going to be 1 minus 0.75, which means P is going to give us 0.25. So that's 0.25 in kilonewton in this case. All right, so that is how we could have calculated P in this case. That's 0.25 kilonewton. All right, so that was question 3.31 from this diagram. All right, again, from this same diagram, now we are given to determine the magnitude and nature of the forces A, B, and B, C in the frame. All right, so we need to know what is representing A, B, and what is representing B, C, and also their nature. All right, so let us check from our diagram, since we have calculated this part of P. All right, so if we are to check here, we are going to consider, in this case, our B is supposed to be somewhere. A is supposed to be somewhere here, B is somewhere here. All right, so remember that I said we can actually work with our forces, upward forces again, but from which concept now? Instead of working from this force that you are given, we can work from AB, this force of AB with angle of 30 degrees. So meaning to say we can be able to actually calculate this force. All right, so that's 3 point, all right, so let's save 3.32. So from the concept of upward forces again, we can say the sum of the upward forces must be equal to the sum of the downward forces. Okay, let's check what we're gonna have if we formulate an equation. So meaning P is going up in this case, which is 0.25, must be equal to the downward force, meaning to say you're talking about AB, which is on top. So AB now, as a vertical component, it is going to be AB sine of theta. That's as a vertical. Remember, vertical components, they carry sine theta. When we are saying upward forces and so forth, we are talking about vertical components in this case. So the upward must be equal to the downward, meaning to say we are going to have AB sine of 30 degrees because the angle is taken from the force to the horizontal. So we have formulated an equation where we can solve AB in this case. So this can give us the value of AB. All right, so if we divide by the sine of 30 degrees both sides, by the sine of 30 degrees both sides, we obtain AB. So meaning to say AB is equal to 0.25 over sine 30. So that's 0.25 over the sine of 30 degrees. All right, so what are we going to obtain for AB? So AB is going to be 0.5. So that's 0.5 kilonewton. And AB, as we can see, AB being a vertical, this is a strut. So that's AB is going to give us a strut in this case. All right. So with the same information or the same idea that we are given, we can also use it for BC, because remember, we also need to find the one for BC. All right, so if you check B and C, they're actually in the same concept with A and B, B and C. So meaning to say we're simply going to apply the same idea in this case of having our upward forces being equal to the sum of the downward forces. So meaning to say the one that is going up this time, we are referring to R. We are referring to this side now. So R is the one that is going up. So meaning to say 0.75 will be equal to BC. This is the one that we are working with BC together. So we are referring to BC sine of theta. Remember, vertical components, they use sine of theta, the angle between the force and the horizontal, which is 60 degrees. So that will be sine 60 degrees. All right. So meaning if we divide by sine 60 degrees both sides, by sine 60 both sides, we obtain the value of BC in this case. All right. So this is going to give us the value of BC, which is equal to, that will be something like 0.866 and so on in kilonewton. And as we can see, the BC and AB, they are the same. So meaning to say this is still a strut. All right, we are still focusing on a strut. Okay, so that was our question in this case, or that was what we are given and how we are supposed to attempt this typical question. As you can see, 16 marks for everything on this question. All right, so that's it, guys. Let us continue to work with more question papers as we are preparing for the exams ahead of time. But for now, that's it from Maison African Motives. Till we meet again.